Vanakkam one and all. We will discuss problem number 34 of exercise 5.1. Here they are asking us to find all the points of discontinuity of f where f is defined as mod x minus mod x plus 1. So when we consider about mod x function, this mod x it is a non-negative value. So the function can be defined like this. Mod x will be x for all x greater than or equal to 0. And mod x will be minus x for all x less than 0. Yes, this is how they have defined. This is the definition of mod function. And when we consider about mod x plus 1, this mod x plus 1, when the value of x is minus 1, it will be 0, and the value of x is greater than less than, when the value of x is less than minus 1, what will happen? When the value of x is less than minus 1 means the inner term will be negative. So when the value is negative inside, while writing that you have to write minus x plus 1. And for all x greater than or equal to minus 1. In this case, you will write x plus 1 as it is. So this is the way of defining the function mod x plus 1. So we will discuss the function for all x less than minus 1. So the function value for all x less than minus 1. For all x less than minus 1, f of x is mod x minus mod x plus 1. If the values of x less than minus 1, in this case it will be mod x will be when the values of x less than 0, I mean when it is obviously less than minus 1, so the value will be minus x. So we will get minus x minus and mod x plus 1. So when the value of x is less than minus 1, mod of x plus 1 will be minus x plus 1. Now we will write minus x, minus minus will be plus, so we will get x plus 1, which is nothing but 1. X gets cancelled, so we will have 1. So the function will be a constant 1 for all x less than minus 1. Okay, so now we will see the function for all x greater than 0. Because for all x greater than 0, okay, greater than 0, the function mod x will be mod x. Okay, and here when the value of x is greater than 0, so we will have x plus 1 as it is. So we are considering the function at for all x greater than 0. So again the f of x is mod x minus mod x plus 1. Now in this case, for x, the x terms, the inner terms are positive. When we have the positive terms, we will write the term as it is. Okay, and minus again here when the values of x are positive greater than 0, we will have the same positive term x plus 1. So we will get x minus 1. So x minus plus x minus x gets cancelled, so we will get f of x as minus 1. Again it will be a constant when the values of x are greater than 0. Now we will discuss about the function in the interval. So now we got for the entire real line, for all x less than minus 1, for all x less than minus 1 in this part, okay, for all x less than minus 1, the function is f of x equal to 1, which is acting as a constant function. And for all x greater than 0, okay, the function is minus 1, again it is a constant function. Now we will look at the function in the interval minus 1 to 0. Okay, So we will calculate the function in the interval. So x value is in the interval, okay, -1 to 0. So what about the function? So f of x will be, again the function is mod x minus mod x plus 1. Here when the value of x is less than 0, okay, so we will have, according to the definition of mod, we will get minus x. I am putting minus x, minus, inside we have x plus 1. When the value of x is exactly -1, the entire term, -1 plus 1 will be 0. The entire term will be 0. If it is like something -1 by 2, minus 0.5, like that, means we will get a positive value. Since, okay, and even if the value is 0.1, minus 0.1 plus 1 will be a positive value. So for all this, okay, for all x from this interval will give us the term as non-negative term, okay. So I will write x plus 1 as it is, because the inner term is positive. So by the definition of mod, we will write the term as it is, okay. And if the inner term is negative, means we will put minus sign in front of that value. As we are getting non-negative value, we are writing the term as it is. So now we will get minus x minus 1. So this is nothing but minus 2x minus 1. So this is the function, this is that f of x for all x in the interval closed -1 open 0, okay. So now we have defined the function, okay, in 3 different intervals, okay. That is like in the first case we have defined for all x less than -1. So that will be like this interval. And in the second case, for all x greater than 0, so 0 to infinity. And in the third case, we have defined the function in the interval -1 to 0 open. So we have covered the entire real line now. So we will write the function, we will rewrite the function with this interval, and we'll check the continuity of the function in the interval, okay. Here I have represented the same given function in the interval forms. Now we will check the continuity of the function. So for all x less than -1, the function is having one as its expression. So it is a constant function. Now we will check the functional value. So for this, limit x tends to 1 from left hand neighborhood. So x tends to -1 from left hand neighborhood of the function. It is a constant one, it is 1 actually. In the left hand neighborhood of -1, we will have the function as 1, which is a constant one. We know it is a continuous, and we can take it as a limit of the function, left hand limit. Now we will calculate limit x tends to -1 from right hand neighborhood. In the right hand neighborhood, we have the function, okay, we have the function as -2x minus 1, -2x minus 1. So now here in the right hand neighborhood, we have elements we have elements like this, -1 plus h, where h is a small positive real number, right? So here it is a right hand neighborhood. So and here we will replace x as -1 plus h. Again here, as x tends to -1, h tends to 0. So this one will be limit h tends to 0 -2 -1 plus h minus 1. Now we'll apply h as 0 over the expression. Over the expression we will get -2 -1 plus 0 -1. So this is -2 into -1 will be +2 -1, which is 1. So here left hand limit equal to right hand limit. Now we will calculate the functional value. When the value of x is -1, when the value of x is -1, the function is -2x minus 1. So f of minus 1 will be minus 2 into minus 1 minus 1, which is 2 minus 1 again 1. So here we can say the function's left hand limit and right hand limit equal to the functional value. So we can say the function is continuous at minus 1. Now we will check the continuity at 0. Okay, and we'll check the continuity at 0. In 0 we will consider the left hand neighborhood. In the left hand neighborhood of 0 we have the function as minus 2x minus 1. Okay, so limit x tends to 0 from left hand neighborhood. X tends to 0 from left hand neighborhood minus 2x minus 1. Again, in the left hand neighborhood of x we have elements as 0 minus h, where again h is a small positive real number. Again x will be 0 minus h. As x tends to 0, h tends to 0 here. So we will get limit h tends to 0 minus 2 0 minus h, because it is a left hand neighborhood, minus 1. After replacing h as 0 over the expression, we will get the entire, okay, we will get this term as 0. The full term vanishes. Okay, so we'll remain with, okay, I'll write, we'll remain with minus 1. Okay, now we will calculate the functional value. According to the definition of function, when the value of x is 0, the function will be minus 1, which is a constant function. So limit x tends to 0 from right hand neighborhood. In the right hand neighborhood, the function is a constant function, which is minus 1. So the limit, the values of x approaches to that constant does not affect the value. Okay, so we will have minus 1. Okay, and we know the functional value at 0 is minus 1 according to the definition. So here we can say the function is continuous at 0. And again, when we see these points, okay, we have the function minus 2x minus 1 at the interval minus 1 and 0, closed interval minus 1 and 0 open. So we have checked at the points, boundary points, minus 1. So at the minus 1 the function was continuous, and at 0 it was continuous, and in the interval it is minus 2x minus 1, which is a polynomial. It is a continuous function. So there is no point of discontinuity for this function. So we will say the function is the function f of x equal to mod x minus mod x plus 1 is continuous on entire real line. So there is no point of discontinuity for this function. Thank you.